Hello, my name is Styliani Roufou. I'm coming from the University of Malta. I belong to the Protect ITN Marie Curie project. My supervisors are Dr. Sholeem Griffin, Professor Juan Impe, and Vasilis Valdramidis. The topic of my project is to evaluate the microbial changes in dairy wastewater under climatic stress conditions. Today I will present a study done in our laboratories, and it's based on the development of a chemical indicator in the quantitative estimation of dissolved carbon dioxide in water. From the title, you can understand that I'm focusing on dairy wastewater. And from the today's study, I will try to explain how can the climate change affect dairy waste. From the flow of the dairy waste, we can classify the industrial waste into two categories, the solids and the liquids. I focus on liquids because they are high in nutrition such as protein, lactose, fat and oils. Also, the level of total solids is high. Some new approaches to reuse the waste are the production of useful byproducts such as biogas, ethanol or human supplements like protein powder or infant milk. But these techniques are expensive and not commonly used. Commercial and traditional practices for the liquid waste are dumping them on the land for irrigation or fertilization or use them as an animal feed. These techniques may be linked to the spread of diseases through the cows or the food chain. The reason is that based on the forecast for the climate change, we expect an increase in the concentration of carbon dioxide in the atmosphere and an increase or decrease in temperature in different areas. Climate changes may affect the risk to food safety and public health. Why could this happen? We know that the carbon dioxide naturally dissolves in the water and is dissociated into carbonic acid, hydrogen ion, bicarbonate and carbonate. The solubilization of carbon dioxide is temperature dependent and its level affects the pH of liquid in which it dissolves. So how the pH reduction and the change in temperature will affect the dairy waste that is disposed of in the environment remains unknown. Some assumptions are that it may affect the milk yield, the cow's mortality and the product safety. Furthermore, dairy waste considers an excellent substrate for the growth of microorganisms. For this reason, climate change forecast requires new approaches to assess the effect of carbon dioxide on microorganisms and the substrate where they grow. We explain why we focus on dairy waste. Now we move to the aim of this study, which is to quantify microbial dynamics under climatic stress within the dairy sector. The objectives are to develop a colorimetric method for estimating dissolved carbon dioxide in water. We will use the information that we will get from the dissolved carbon dioxide in order to evaluate the effect of pH reduction and temperature change on E. coli strain in a waste simulant. Let's move to the material and method of this colorimetric study. Phenol red was used as a sensitive pH detector that changed from yellow to purple pink in a pH range from 4 to 8. Sodium bicarbonate buffer was used to stabilize the pH. A comment here is that we filter the solution to remove the remaining crystals. In order to be able to change the color and to know the pH of the exact color, we use formic acid in different concentrations. Here we can see the chemical reaction that takes place, and we have as a product salt, gas, carbon dioxide, water. Also, we have the convert form of phenol red from base to acid, and that's why we have this color change. We associate this color change with the color change that occurs naturally due to the dissolved carbon dioxide in the solution. We can see here the color change after 5 minutes in the concentrations of carbon dioxide above 0.2%. The chemical reaction that is happening is this. The carbon dioxide combines with water to produce carbonic acid, protons, bicarbonate, and carbonate. The color change results in different optical density readings, which were quantified using a microbial spectrophotometer operating under controlled temperatures and OD and carbon dioxide conditions. We used two different wavelengths at 450 and 560 because we know from the literature that these are the maximal peaks for the phenol red. Using the equation of pH and the acidic equilibrium constant of the bicarbonate system, we can estimate the concentration of protons, and we can calculate the dissolved carbon dioxide into the solution. This is the process for estimating dissolved carbon dioxide. And now we move to the results. The first step was to optimize the concentration of phenol red that we have to use. The concentration of 0.06 grams per liter is commonly used for tissues culture media, and we can see the color change by our eyes. In our case, we measure the absorbance, we use a sensitive device, and this concentration gave us low readings. So we have to choose from these 5 concentrations. We found that the level of 0.02 and 0.01 grams per liter gave us better OD readings. So we compared both of the wavelength and both of the concentrations under different levels of carbon dioxide in the system, and we conclude that the best concentration that we have to use is 0.02 grams per liter at 560, is the green line on the second graph. The reason is that it gave us better range and bigger range of OD values. Having optimizing the concentration of phenol red, we proceed to the next step, which is the generated of a standard curve using the OD and pH readings of the formic acid at 37 degrees. The curve has R square of 0.92 and it's a good value. As we can see, adding less amount of formic, the color of the solution is between pink and purple. The pH was between 7 and 8, and the OD readings were higher than in the lower pH. Using this graph, we can estimate the theoretical pH by using as OD the readings coming from the phenol red with the dissolved carbon dioxide. And after that, via the acidic equilibrium constant of the bicarbonate system, we can estimate the amount of dissolved carbon dioxide into the solution. And we end up to this graph that correlates the dissolved carbon dioxide with its level in the system. We can see that when we use 10% of carbon dioxide at the system, the dissolved is almost 2.4% at 37 degrees. Last but not least graph is this one, and we compare two different wavelengths and we use the above data. We can see that the dissolved carbon dioxide into the solution over the time reach a plateau after between 5 and 7 minutes. The dissolved carbon dioxide in the solution reach a plateau. This means that the concentration of the sodium bicarbonate in the acid are similar. Other point that we can highlight is that as we increase the concentration of carbon dioxide into the system, in the first 5 minutes, there is a sharp and faster dissociation of the carbon dioxide to carbonic acid. This study concludes that we can correlate the dissolved carbon dioxide with OD readings. We can estimate the dissolved carbon dioxide and pH values, and finally, this study will be conducted at different temperatures because now we have done only at 37 degrees. We will use the prediction data for carbon dioxide emission and temperatures, and we will investigate the effect of various climate scenario as expressed in temperature and dissolved carbon dioxide on the microbial proliferation. I would like to clarify the last point, and I will say that we will use the knowledge of the dissolved amount of carbon dioxide to understand better the impact of the future changes. We will, on the dairy waste, we will produce a laboratory whey by using a low-fat cow's milk by adding microbial RNA, and we will see the effect of this pH reduction and temperature change on it. Finally, we will use this whey as a substrate to grow E. coli strain. We have already generated E. coli GFP strain using the plasmid as a donor for the GFP gene for the production of plasmid. The GFP protein is preferred because of its ability to fluoresce. And we can see here that it turns green when the cells are alive, and over the time it turns red, and that means that the cells are dead. We will use this color change, and we will, in order to apply kinetics assays, we will use the E. coli GFP strain in order to correlate the microbial responses of it grown in the laboratory whey with diffuse carbon dioxide. So this is mainly the layout of my project. Thank you for your attention.